Hello and welcome to section 2.6 on three-dimensional bond line structures. Your book goes into this in some detail, but one important thing to note is that I want to give you a little bit of extra detail. So in order to do the best in terms of knowledge gaining, please feel free to look at both resources. Now, please, right at the beginning, excuse me, because I'm going to be doing some drawing here in the notebook for section 2.6, but I don't have my pen and I must draw with my finger. So if the things are a little more messy, please accept my apologies. I swear to you, I'm doing my best. Um, right. So bond line drawings, as we have seen, can look like this, where you have, let's say, a bromine here and a hydrogen here. And this tells us that more or less you have one, two, three carbons, and the second carbon has one bromine attached to it as well as one hydrogen, right? But one thing it doesn't tell us, unfortunately, is where in 3D space those hydrogens are actually, or the hydrogen and bromine are actually sitting, because the H and the Br have no specific um, 3D space details. What does that mean? It means this. It means that we could either draw the H on the left side, see, kind of drawing it like that, or the bromine on the left side, and it doesn't matter based on the drawing that we just made. So how do we how do we address this? How do we make this into something that makes a little more sense? Like how can we understand where in physical space, the left or the right side, the hydrogen and bromine are? And the way we do that is through what's called wedge and dash notation. So instead of having kind of ambiguous placement of these things, now instead, I'm going to move these around. Here we go. Oh, come on. There we go. Okay, now instead, I'm going to draw these using wedge and dash notation so that you can see where they would be in that regard. Okay, so first we draw the same carbon system as before in each one. There we go. So to have, oh, actually, no, we're going to do this a little differently. Here we go. Here we go. Okay, so if we're going to have the hydrogen on the left and the bromine on the right in one case, and in the other, the bromine on the left and the hydrogen on the right, then what we need to do is we need to add in a wedge for one and a dash for the other carbon. In the same way, we need to add in one a wedge and a dash. Let me draw that a little better. Again, with my finger, it's kind of hard, so I can't, it's harder for me to draw these very well, but I'm gonna really try here. Um, maybe I should use, yeah, that's fine. So the dashes are supposed to look very bolded on the outside. In your book, you can see a really good example of this. And the dash bonds here kind of look like that, where they kind of get bigger as they go out. So what this is telling us is that the one with the wedge, the bolded one coming out at us that gets a little bigger as it goes, that one is physically pointed at us. Okay, and so it's kind of coming out of the screen towards you, and the one on a dash is physically going into the screen away from you, while the H and the BR are both in the plane of the screen. So using this wedge and dash notation, you can actually see in 3D space kind of where those two molecules are. And this is the time when having a molecular modeling kit would be really helpful, because then the molecular modeling kit can help you see the 3D spatial characteristics of these molecules. I'll put up some videos later in the week using the molecular model kit in just such a way so that you can tell kind of where in 3D space these molecules are and what that means in terms of the drawing of each molecule. But more or less, I'll give you one more example, because that's really all we need for now. So if we were to look at a molecule like this, let's say it's CH BR, oh, sorry, BRI. So that means, oh, it's and Cl. There we go. So now the carbon is attached to both bromine, iodine, chlorine, and the hydrogen there. So if we were to draw this in bond line notation, we would draw it, who knows, maybe like this. And you know, the H is out there somewhere. And then maybe you could even draw it like this, because like I said, without the wedges and dashes, it's really hard to say where each thing is, right? But if you were to draw this in a wedge and dash form, now Cl. Now you can say for sure that the bromine is coming out at us and the chlorine is going in. And there is no ambiguity there, because now that we have locked in where these atoms are in 3D space, the drawings are not equivalent, because this drawing is not equivalent to the one I'm drawing right now. Here we go. Where now that's a chlorine here. And here's our hydrogen. And here's our iodine. And you might say it looks like it should be the same, but, and here's what we're going to leave with in this lesson, it's not the same, because if you take one, come on, even though it looks like it could be the same, and you try and superimpose it on the other, it doesn't work. The bromine comes where the iodine should be, and the iodine comes where the bromine should be. So now that we've used wedge and dash notation, we're locking these atoms into space, and they're not the same as drawings that don't have the wedge and dash notation. So we'll go over this a lot more in the coming days and weeks, but for now, this is section 2.6.